Hi, I'd like to take a few minutes to introduce you to a throttle that I developed. It's actually a wireless throttle that I developed for DCC++. You may recall that DCC++ is a completely open source Arduino-based DCC system. The throttle connects to this controller, the DCC++ controller. The thing that's unusual is that it uses a radio link between the throttle and the controller. A very simple, very inexpensive radio link. I've got a couple of them here. About $5 for each end of this, so you're going to need to spend about $10 on the wireless interface. And other than soldering on a small antenna and adding a few pins for a header, there's not much that has to be done with this. A little bit of configuration that I'll show you, and it does a beautiful job of connecting the two wirelessly. In addition to that radio unit, I've switched it over from using a potentiometer to adjust the speed to using a rotary encoder, which you can spin as much as you want in any direction, but this will range the speed from 0 to about 126. You need a power switch to turn it on and off. For batteries, I use two cell phone batteries. These are 3.7 volt 670 milliamp hour batteries. Wire two of them in series. It gives you 7.4 volts, which through a voltage regulator is taken down to 5, and all of that is mounted on a circuit board. This happens to be a circuit board for a different project that I was working on, but it lends itself nicely to this throttle. If there's enough interest in the community, folks working with DCC++, I'd be glad to design a circuit board and make that available to folks. This, again, is one of the throttles. It has a keypad on the front that's used to enter things like locomotive numbers, addresses, if you will. It's also used to activate functions. If you wanted to get the bell going, you can press number 1, and so on. The other thing that I didn't mention is it has a two-line liquid crystal display up here with an I2C interface that hooks up directly to the Arduino. Speaking of Arduino, it's a Pro Mini, very inexpensive and readily available. This is one that just came out of the bag, and I'll get that soldered up and ready to go. In this video, I'd like to show you how the throttle goes together. I'd like to show you the configuration of the radio, how you can use one or two throttles with the DCC++ base station, and how you can use that to control one or more trains. Before we get started on building the throttle, or at least exploring how it's built, I'd like to remind you that all of the information that's being presented on this video is also on my webpage, with lots more photographs and images and parts lists and so on, along with a very important piece of information, the schematic that shows how the whole thing is wired together, because you may or may not want to use a circuit board. You certainly could use a piece of purse board and do some hand wiring and get it all working. This is a prototype. This one happens to have a potentiometer instead of a rotary encoder, but it's basically the same thing, has the same keypad, same display. And there's the circuit board, which has been mounted on the back of this piece of plexiglass, along with the Arduino, a connection for the keypad, a connection that goes to the liquid crystal display. You may notice that there are pins here on the liquid crystal display where you would normally plug in for connections, but because it would stick out too far and go beyond the edge of the case, I just soldered wires directly to that. But the construction is very straightforward. You obviously can change it any way you want to accommodate your interests and needs. Now, this case was not designed for a battery. This was designed for wired connection to the DCC++ controller. All you had to do for that was to connect 3 wires plus 5 ground and the transmit from the serial port directly to the DCC++ controller, and it works beautifully as a tethered non-wireless unit without a battery. While we're looking at this, let me show you a little bit about the case. I wasn't sure how to design a case for this, and then the fact that I have a laser cutter kind of brought a case to mind. Making this is pretty simple, but making it 3D is a little bit more involved. This is just a piece of 1/8" plexiglass with some labels cut into it, a hole cut for the LCD display. And by the way, the Corel Draw file is available on the web page. Notice that depending upon whose liquid crystal display you get, this rectangle here might need to be adjusted in size. But what I did was I built this up in layers. There are additional pieces of plexiglass that have been cut up to fit on there. I got those bolted together. Let me take that out real quick. And in order to make a 3D case, you simply stack these pieces. There's another 1/8 inch piece. Here's a 1/4 inch thick piece. Here's an 1/8 inch, actually it's a 1/4 inch piece that has a notch in it to support the either a plug for power or to let the wires out for the wired. Here's another 1/4 inch piece, and then the back is an 1/8 inch piece with a little labeling cut onto it. You put all those together, put a couple of bolts through and nuts on the back, and you've got a nice, easy to fit in the hand 3D case from a laser cutter. I'll show you a little bit more about the laser cutter in a few minutes. Here we are in Corel Draw looking at the case parts, the 6 pieces that make up the case. You may not be able to tell too clearly on the video, but some of them are in green. You can see the lettering here is in green, and some of them are in red. The important thing about that is the laser cutter has the ability to do different colors at different intensities. So what we're going to do in order to start printing a case is highlight the part we want. I don't have a big enough piece of plexiglass to cut all 6 pieces at a time. And I've highlighted these 2 sections, and there's a little button up here that's made by a plug-in for Corel Draw from the software that comes with the laser cutter. And in a moment we get the Thunder laser controller, and what we've done is transferred those 2 parts onto or into that software where we can actually operate the laser cutter. The important thing over here, notice that we've got red and green over here on the right hand side. The red is set up to cut at speed 8, which is 8 millimeters per second, pretty slow. At power 42, that happens to be full power. The green is set to cut at speed of 80 millimeters a second, so it's very quick. And the power is about 35, which is a lower power. The important thing, though, we have to tell it what order to cut these in, because obviously if we cut the outline first, the pieces could fall out and not be aligned properly when the text and holes and things are done. So all you do is you click on this little icon up here, click on the outside edge of that one and say do that one first, click on the outside edge of that, do that one first. So those 2 things have been told to be cut first. Actually, I wanted to be cut last, but you'll see how I do that in a second. Click on this to add everything. So now we've got the outside edges being done first. I simply say reorder, which switches the whole thing around so that those 2 outside edges will be cut last. And now what I want to say is OK, and we're ready to cut. I'm going to go over to the laser cutter in a moment, and I'm going to click on this start button using a laptop that I have that's mirroring this particular screen. So we'll do that here in a moment. Okay, we're going to move from the main computer that's over here and walk across the basement to where the laser cutter is. You can see it's rather a large beast. The shipping weight was well over 200 pounds. The reason it's over here is because it needs to be vented to an outside window, and you can see the silver vent that goes up there to the window. I put a piece of plexiglass in there that's about 8.5 inches square, which is sufficient for what we want to do. And next to that, I have a laptop that's mirroring what's going on the big computer over at my main workstation. And I'm going to reach down here to the side. I don't know how well you can see it, but there's a start button. I'm going to click the start button. And with a little bit of luck, there we go. The laser cutter has started. It's cutting some holes for mounting. Now it's doing some engraving. You can see it putting some lettering in there. You may recall that that was being done at fairly high speed, so it doesn't cut clear through. The lower speed cutting is going to cut clear through the plexiglass. Now normally I do not have the top on this open because it puts out a decent amount of smoke. And of course the vent doesn't work very effectively when the window is open, or when the top is open. Okay, it's almost done with the lettering. Couple more mounting holes. All right, now it's cutting out. This is going clear through, and if you look carefully, let me back off the camera a little bit, you'll see smoke coming from underneath, which indicates that the laser beam is cutting clear through. This is cutting out the inner part of one of the spacer sections. And this whole thing is probably going to take 4 or 5 minutes. You are certainly welcome to fast forward ahead and skip it. I may actually edit some of this out because it's kind of like watching grass grow. Okay, I'll get in real close. You want to make sure that you don't put your hand in the wrong place when you're doing this, because the laser itself is in the back of the machine and the beam is brought forward with mirrors. And of course, even though the mirror part of it is not focused, here it's cutting out the little port for wiring. Okay, now it's cutting out the main section on the right-hand piece. But as I was saying, if you happen to get your hand in the beam where the mirror is transmitting it from one spot to the other, even though it's not a focus beam, it's going to ruin your day, because it's a 50-watt carbon dioxide laser. The beam itself is invisible, it's infrared, so you have to take a lot of care. If you do notice a red beam at the end of the head of the laser cutter, that's just a red LED laser that is pointing down to show you where it's traveling. The beam itself is not visible except where it hits the plastic, and you'll see it glow a little bit from time to time. You usually see a white image. Okay, that's almost done. It's coming around the side. Okay, about another ½ inch of cut. All right, that piece is done. Now it's cutting through the outer edge of the spacer piece. There's also a blast of air coming out of the orifice where the laser comes out. That helps to clear the cut area. It also helps to keep the mirror and the lens inside of that structure from getting contaminated by smoke. Okay, we're coming down. We're about ready to make a turn here. And we're up to about 4 minutes and some seconds. Now, while it's doing this back cut, I'm going to show you the display. The display is really neat on this because it's actually showing you, don't know how well you're going to be able to see that, how it's progressing for the cut. This is the control panel. Okay, let's go back to here. And we're done. Now it's safe to put your hand inside, and you see what you wind up with. Once I peel that yellowish protective material off, we're done. There's the inside of that, and here's the spacer, and it's got that notch in there to allow power to go through. Turning on the throttle, you'll see, first of all, it says hold button to adjust number of locos, and it gives a little copyright notice. This is the main screen. In the upper left-hand corner, it says speed is now 0. To the right of that, there's an arrow or a caret pointing to the right, means it's going forward. Then L equals 03, which means we're set for loco number 3. And the number 1 on the upper right-hand corner means this is the first locomotive that we can work with. And those zeros across the bottom just show the status of any function keys that we may have used. In order to speed loco number 3 up, I simply grab the rotary encoder and turn it to the right, and you'll see the number there after S incrementing all the way up to 126. You can change that if you wanted to have some other value simply by editing one line in the program. And I'm decelerating. The other thing we can do, of course, is to press the center of the rotary encoder. It's a button as well as an encoder. and you'll notice the direction changes. So if we're up to speed of 20, for example, and press that, we can reverse, forward, reverse. It does not do any gradual decrease or increase in speed. It simply changes it, and it's up to you to set your locomotives to react to that in a little bit more civilized way. Down at the bottom of the keypad, there are two important keys, the star and the pound. If you hit the pound key, you'll notice that now L changed to 1, 2, 3, 4, and it says that's locomotive number 2. And then we're back to number 1. We're only showing 2 locomotives. And that's a good thing for some applications. Again, I'll show you more about that in a moment. If I press the star button down here at the bottom, it gives me a chance to set the DCC address for number 2. And let's say it's 1451. I simply type 1451, and now loco 2 is 1451. It remembers that, stores it so that the next time you fire it up, it will be there. All right, let's turn it off for a minute. And you may remember when it first powered up, it said hold the button in order to set the number of locomotives. We're set for 2 right now. I'm going to hold that button, power it on, and what it does now is says, okay, loco number is now 2. Give me a new number, 1 through 4. Well, let's press 4. Now, it starts up again. If I press that pound button, I've got loco 1, which is number 3, loco 2, which is 1451, loco 3, which is 3333, and loco 4, which is 4444. So you can set 1, 2, 3, or 4 locomotives. It makes it very convenient. If you're only operating 2, why should you have to skip past number 3 and number 4 in order to get back to the first one? So that's a quick overview of the software. A lot of variables and other things can be changed before you program it, but the number of locomotives can be changed just by holding the button down when you start it up. I have a very basic loop of tracks set up for testing. I have 2 locomotives. One's actually a trolley. It's number 1451, and the address in the throttle is 1451. This diesel is set up as number 3. The DCC controller, which is just the Arduino and the motor shield, rather, are set up here. They're connected to a 14-volt lithium battery and then to the track. And what I'd like to do is show you how I can operate 2 locomotives with the one control. I'll turn it on, and it comes up with 1451, which is the trolley. I'll turn the knob clockwise, and you see it speeding up. Of course, I can hit the button and reverse it again. And then if I hit the pound button, you hear the sound on the diesel kick in, and I'll turn him a little bit clockwise. That one has a sound card, so I can do the bell and the horn and so on. Speed him up a little bit. And the trolley is about ready to come into the same position. I'm going to stop the trolley. Again, switch over to number 3, the diesel, bring it around. And one thing I'd like to mention, if you need an emergency stop, if you press the star, which is for changing the address of a locomotive, it immediately shuts the power off to the motor shield. And if you just want to abort that without entering a new address, just hit the pound button. It takes you right back to where you are. But it's an easy way to kill the power. For the last test, I'd like to show you what happens when you have 2 throttles connected, of course, to one radio receiver on the DCC controller. I've got the one on the left set for the trolley, which is 1451. I'll set the one on the right to 3, which is the diesel. And if I bring the trolley up, let him go down the road a little bit, and then bring the diesel up, sound his horn. There we've got the diesel and the trolley both operating from two different throttles at the same time, and they're not interfering with each other. That's the part that I found really kind of amazing when I stumbled upon the fact that you could use two of these throttles with one receiver or one DCC command station, and it works very, very well. Now I'm going to show you something on the computer here in a moment that will show exactly what's happening with the data that comes from these devices. I'd like to demonstrate what happens with the throttles when two of them are transmitting data at the same time. This is a terminal program called CoolTerm. It's connected through a serial port and to one of the radio devices, so that anything that a throttle transmits is picked up by this radio and put up on the screen. You'll see when I turn the throttle on, it gives me the date and the version number, and if I turn the throttle, you can see Loco 1451 is set to speed 8 in a forward direction. If I push the button, it goes to a reverse direction, and so on. If I turn on the other throttle, again, the date and the version number, and I'm going to switch to Loco number 3, and again, if I turn this to the right, I get up, let's take it up to about 50, and let's take this one up to about 50. So it's sending the packets, they're not interfering with each other. As a matter of fact, I can grab both knobs and turn them together, and I get no interference. I get completely clean data going to the DCC unit so that it works beautifully. I was quite surprised that this happened and quite pleased, because it makes using two throttles with one DCC system a very, very easy thing to do.